here live on YouTube in our live stream. Warm welcome everyone to our SAP Community Call. Very excited to see you here today. It's all about accelerating your machine learning efforts and benefiting from our new capabilities in the SAP HANA Cloud AutoML. And I'm here today with Christoph Morgan, as I said, from the SAP HANA Machine Learning team, Product Management, Predictive and Machine Learning. He's our Senior Director. So he's our expert today that you can use to shoot your questions, any questions that you have in the area of SAP HANA Cloud Automated Machine Learning. Please use this SAP Community Call to address your questions to Christoph, because we have enough time towards the end of this 60-minute live stream to address your questions. And I hope this is not your first SAP Community Call, so I hope you know that we use the YouTube chat functionality to ask the questions. I will also share a lot of useful links during the next 60 minutes. And with that being said, I'll now hand over to Christoph.
Thank you so much, and hello everyone, also from my side. I'm going to share my screen now, and then we start right away with the presentation. So, yeah, today I'd like to introduce you to our new capability in HANA Cloud Machine Learning, which is our RML Framework. I'd like to kind of take you through a couple of capabilities which are fairly new. And before I'm going to do that, I actually want to give you a brief refresher. There may be some of you who are new to HANA Machine Learning or the HANA Cloud Machine Learning capabilities. We've had a community call earlier this year where we introduced the topic. And we'll just review that for 5 minutes and then go into the new topic of the AutoML capabilities with the Predictive Analysis Library and how it can be used from the Python and R machine learning clients. We will demo multiple scenarios and then have enough time for the actual Q&A. So as a refresher, SAP HANA Cloud provides a rich set of advanced analytical processing capabilities. Machine learning is one of the areas. Besides spatial, graph, and document store, JSON processing capabilities, we have multiple AI function libraries, one automated predictive library, our classic AutoML library, as well as our Predictive Analysis Library, which is our expert machine learning algorithm library. We will look at that now in more details. And if you use both on HANA Cloud, you get certainly the cloud advantages of top, which are in the area of real-time data federation from other cloud sources, from on-premise, from your data lake, and of course, the HANA Cloud scalability and elasticity capabilities. With that, you can build rich, intelligent applications on SAP BTP, basically our cloud business technology platform. If we speak about machine learning in SAP HANA, we speak about these classic machine learning scenarios, which circle around mostly about classification, where we'd like to predict categorical value, like is a customer likely to churn or in transactions to be fraudulent, or is a customer likely to buy a new product, so buying behavior, or regression, which is basically the same. However, we predict continuous value and not a singular value. So it's a price, a cost value, a sales value, something like that. And then if we take the numeric continuous value and map them onto a time scale, then we speak of time series analysis and forecasting, where we'd like to predict a horizon number of time values into the future. So that's time series forecasting, very, very common in SAP application and with your SAP data, and basically also the most common scenario where we see our machine learning libraries being adopted. There are other libraries which are less frequent and other scenarios here like clustering and outlier detection, etc. The Predictive Analysis Library is our expert algorithm libraries, where we implement trending algorithms indicated kind of by market trends, like gradient boosting based algorithm, random forest, profit in forecasting, where we design a C++ implementation of the algorithm designed to perform very fast at the in-memory HANA processing speed. We support real-time inference for your data stored in HANA, of course, and segmented invocation of process, typically in forecasting, where you're not modeling a single forecast, but maybe hundreds or thousands of forecasts in parallel on, let's say, store, location, product lines, whatsoever. Explainability is a key capability for prediction and classification and regression, where your users like to understand how the model came up with a given predicted value or classification, for example. And yeah, all these capabilities are certainly leveraged by many SAP applications like integrated business planning, very strong stakeholder and user of our forecasting capabilities, or S/4HANA embedded AI scenarios, leveraging the PAL and also the automated predictive library algorithm. In HANA Cloud, you get the advantage of every quarter we have 15 or 20 enhancements and new algorithms delivered by the PAL library. So if you run on SAP HANA Cloud, you always get the latest enhancements from our machine learning capabilities. And the AutoML framework is one of the key new enhancements we provided this year. For data scientists, we provide these R and Python machine learning clients because we don't want to impose experts to learn the SQL and the SQL interfaces of our algorithm library. So the experts can stay in their environment, expert environment, script in Python and R, but basically execute on the fly in HANA in the database as we generate the SQL calls on the fly and execute them. We provide data into the Python and R environment using as a data frame concept. We call them HANA data frames, which is basically a Python or R virtual data reference to a SQL query against anything in the HANA database. Could be a view, could be a join, could be a table, whatsoever. The clients also provide spatial and graph enhancements for importing, exporting data, also building graph workspaces, etc. And both the PAL and the automated predictive library can be used from the Python and R environments. Additionally, we also provide capabilities to actually create design time artifacts. If you as a data scientist are ready with creating a machine learning scenario, you can then generate design time artifacts, SQL script artifacts, which you can hand over to the application developers. And overall, the benefits and unique value of SAP HANA machine learning is certainly that you can bring the algorithms to the data. You don't need an extra infrastructure to apply machine learning to your data. You can directly add this capability to the core of your applications, running co-located with the data in the SAP HANA database, and we ensure that the algorithms we provide are best in class regarding performance and also low memory usage. So that's our paradigm as we implement the algorithms in SAP HANA. It's a simple architecture, and certainly a data scientist can leverage all the capabilities, as I mentioned, through the expert interfaces in R and Python. The PAL library, our expert library, provides a rich set of algorithms in all the categories, as we can see that here, highlighted in different colors. The algorithms which are new in SAP HANA Cloud are basically the green ones. All the white and orange ones are already available, and blue ones in the HANA on-premise code line. But as you can see, there's a rich set of enhancements and new algorithms which are yet only available in SAP HANA Cloud. And the key area of enhancements, again, as you can see that on the lower left corner, are the AutoML enhancements. If we now look at a machine learning scenario like classification or regression. In the past, we had multiple algorithms with distinct interfaces. And what we have done over the course, let's say, of the last 2 years, that we provided a single procedure user interface, making it easier for the SQL developer and the application developer to integrate a scenario into the application, independent of the algorithm. So the interface is harmonized, and if within a given machine learning scenario, again, you're implementing, for example, a customer churn or business partner churn scenario, then you would always use the same procedure, but maybe switch the algorithm behind the scene. That makes it easier to sustain a machine learning scenario as you enhance the implemented algorithm. But we wanted to take this to another level, another step, providing even more productivity to the data scientist and the application developer to come up with the actual machine learning scenario and the best possible model. And for that, we have added the automated machine learning capabilities in SAP HANA Cloud. And at the core of these enhancements, first and foremost, we are providing pipeline capabilities, implying that we can now compose a sequence of multiple PAL algorithms into a pipeline, which you can then execute for training and predictions and also evaluation. On top of that pipeline concept, we provide an automation framework, which then basically takes all the data processing options, the algorithm options for your scenario, be it classification, regression, or time series, and compares different compositions and also configurations of the algorithms to basically come up with the best possible pipeline to predict your classifier, your regressor, or the best possible time series forecast. We have SQL, Python, and R interfaces. And the targeted benefit is basically the productivity of the data scientist or the expert to build even, build even better PAL machine learning models for increased business value. So now let's have a closer look at the individual capabilities, starting with the pipeline functions. So as you can see here on the right with the screenshot, we can compose multiple algorithms into a single function, pipeline function or estimator function, as I specified it here. So we're using, starting from the data input, we are scaling transformation step, some of the columns in our data set, and then applying a random decision tree classifier. And all that comes together into one model or one pipeline function. The pipeline itself is defined as a JSON structure, and we have SQL, Python, and R methods against which we can use them on top of our JSON pipeline or with our JSON pipeline, or even to create the respective pipeline model or pipeline functions. Here at the bottom, you see some examples. The first one is an extract examples of that JSON structure name, and then we have the arguments, and at last argument is the input data basically. And then you can see two examples of the random decision tree classifier, a single step pipeline where we then give as arguments the parameters, and last the input data. And the third example is basically a chain, as we see the random decision tree classifier. Then the next function is the scaling functions, and at last we provide the input data. But certainly we want to now see how that can be leveraged or how that is applied in application. There's this new SQL function called PAL pipeline fit, and pipeline as the parameter, where we apply the JSON string, and be assured we don't need to manually create a JSON string. There's capabilities for us to create the pipeline object itself. But this is basically how you would then operationalize it in your SQL-based application. The output would be the pipeline model, which we could then use in a evaluation step. Maybe we have some test data and want to apply our pipeline model against the test data. There's this evaluation function. And then there's the predict functions, where we basically then apply the pipeline model against our prediction data and are given back in this screenshot here, we're given back the respective scoring statistics. On top of that pipeline concept, we have this RML framework, which then helps us with creating the pipeline and the best possible pipeline with the best possible configuration in the first place. It's a capability implemented as part of the Predictive Analysis Library, so fully implemented in C++, and certainly also executes in SAP HANA itself, and leveraging all the HANA multiprocessing in memory execution capabilities, and can be governed by the HANA workload management capabilities as well, whereas we want to ensure that we don't overload the systems in the first place. The AutoML framework provides multiple target optimization metrics. We'll see that in a demo example later on. And while the SQL interface may appear a little bit bare metal, or for the, let's say, pro code developer, the expert application developer, the Python and R machine learning client interfaces provide more productivity capabilities like visualization options during the runtime and performance reports and as such. And we'll see that later on. If we now map the algorithm supported as part of the automated machine learning, we see there's a series of algorithms supporting in the data preparation phase, like data transformation and sampling, like time-stamped data transformation, outlier detection for time series, scaling, principal component extraction, imputation methods, label encoding, and feature selection as an also relatively new algorithm in the PAR library, also available in HANA on-premise. And then the actual machine learning algorithms in itself in the area of regression, time series analysis, and classification, including our random forest implementation, random decision tree, support vector machines being popular, logistic regression being very popular, certainly additive model analysis, our profit implementation in the forecasting area, and hybrid gradient boosting, HGBT, our very popular algorithm also in the area of classification and regression. And then the actual optimization framework itself, for those who are familiar with other AutoML frameworks, the genetic algorithm we use for the pipeline optimization, similar to the TPOT framework. And yeah, there are some specific parameters which we'll see during the demo also, which we can leverage to optimize the overall AutoML scenario. The first step you would usually do, and here again, bear with me, that's the SQL example, we would specify or configure the actual AutoML scenario. And we do that with that function AutoML config, where we can specify which operators we want to use or maybe not use, and which are the parameters or the search space, the parameter ranges we want to apply during the AutoML scenario. So that can be adjusted by the respective functions you see here and the AutoML config SQL functions. And the actual invocation is then the AutoML fit function, which in the end has as a key input the pipeline definition, which includes all the operators basically we have specified in the configuration as options to be evaluated. And as in this example, we specify here the pipeline type as the regressor. And then for the actual refitting of the best model, we can again use the pipeline functions, pipeline fit or pipeline evaluate, to probe our best pipeline with test data, or use the predict functions to then predict with the final pipeline, AutoML pipeline, which we have created. On the Python side, or the R machine learning client side, we have these similar methods here to the similar steps, only with the respective Python methods. We initiate a scenario in the first step with calling that automatic classification object instance. We then specify the AutoML scenario by using, for example, update configuration dictionary, and with the fit function actually then call for the execution. And after the execution has finished, we can then collect the best pipelines or inspect the best pipelines and work with them, save them to a model storage location, for example, for later use. And then, as I mentioned before, and we will see that now live, the machine learning clients in Python and R then have the additional benefit of this visual, let's say, objects to monitor the execution progress, as well as to analyze the pipeline performance themselves with some reports here. And yeah, I think the best thing is to see how the capability runs live, and therefore let's look at some demos. All the demos I will show to you today are also available in our SAP samples GitHub repository, where you can see the link on the slide deck. So you can basically, after the session, download the samples and apply them if you have a HANA Cloud instance at hand. Okay, so now let's go into the demo. I'm starting off with a scenario where I'm basically simply working with a pipeline. Maybe I can increase the font size here a little bit. Okay, that may be better visible. So I'm starting off with showing how the pipelines are used. I'm loading the HANA machine learning package in my Jupyter Notebook environment. This is Jupyter Lab, but it could be any other environment. I like the notebooks because within the notebooks we can have the code and the results inline embedded. So therefore it's, I think, quite nice for presentations like this. So I've loaded the package. 2.14 is the current release. And then in order to connect to my SAP HANA Cloud instance, I've created a connection key, which is a local, let's say, encrypted connection information, which you can basically define using the HANA client installed here. And then within your demo files, like this notebook, I basically only refer to this arbitrary key name, which I've defined. So I'm connecting against the HANA Cloud instance. And as I'm now connected, we can see that here it's actually Q3 of 2022 release HANA instance I'm running against. In this small example, I'm uploading diabetes classification scenario file. That's a popular demo example where we want to classify patients by their likelihood to acquire diabetes with certain features like age, blood pressure, glucose, etc. I've created a HANA data frame using this method, create data frame from Panda. So I'm loading the CSV file, and at the same time, I'm loading it up into a HANA database table, defining the structure of the table as I want. I don't necessarily need to do that. And after that, I basically have the data frame created, which we can see here, the data frame is basically a select statement. I can then modify this data frame by adding an ID column. That's what I'm have been doing here. And let's quickly run this again. And then again, displaying the select statement using the head method here and collecting the top 6 rows. I can basically see the content of the file. For that classification scenario, it may be of interest. Okay, how is our target column being distributed? So 267 patients have acquired diabetes, 500 haven't. Then just for your information, there's another nice function, the describe function, which gives us the univariate overview across all the columns. For example, are there any missing values, nulls in the data, which might be of interest. We can then create a pipeline here using this pipeline method. I want to use 2 functions here, the principal component analysis functions to derive principal component as new features based on the input data, and then the hybrid gradient boosting classifier. I'm composing this pipeline here by specifying the algorithms and their parameters and together into this arbitrary pipeline object. And in the end, I use generate the JSON pipeline just for us to see how we basically came up with that pipeline. And now I can plot this pipeline. If I want to have some visual inspections here, see the parameters, maybe in the future this will also be editable, but for now it's just a representation. And can then call the fit method, which I've introduced before. And as we can see here already printed behind that Python method, there's actually a SQL method being called, which is the pipeline fit method. And the pipeline which we have generated above is just the input to the function again. And yeah, certainly I could also then use the predict function with the pipeline model as well, which we'll see in the next example. So we're now adding on top of what we've seen, the bare metal, if you want, pipeline functions being used, the AutoML capabilities for the same scenario. So I'm starting over the same way. I'm importing the package. I'm connecting against the HANA Cloud instance. I'm reloading the data. Could have also reused what I already have, but it's basically the same steps here in all the examples. It's easier than for you if you start over with the example files. And in addition here, I'm splitting the data set into a train and test subset partition, 25% for the testing percentage, and using this stratified partition method here. All right, so now let's go into the AutoML capability, importing the new automatic classification class. And first of all, I'm defining the AutoML scenario. And there's a good documentation here in the PAL documentation, which specifies and gives details which parameters, configuration parameters you may want to apply. What I've been specifying here is I want to have 4 generations. So it's a genetic algorithm. So we optimize the algorithm going from generation to generation. And between the generations, we do some we apply some randomness and some iteration, which we can also more explicitly specify. We start over with 15 different pipelines, and then as we go from generation to generation, we want to pass on the 8 best pipelines or generate 8 new pipelines based on the best ones which we have come up in the generation earlier. we want to stop the AutoML processing from generation to generation if we don't see progress for one, or if I would specify 2 for 2 generations. That's what we're specifying here. Let's leave it at 1. And also for this demo here, we also want to stop if one of the pipeline evaluation takes more than 1 minute. Applying a seed value so we can reproduce what we do in the AutoML, and then specify our optimizations target, which is for this classification, the F1 score for the label value 1. And with elite number, we specify we want to output the 5 best pipelines. So that's the overall scenario which we have defined. Now let's go into some further details. I guess I would need to execute this one as well. So the next step is we start with the default configuration for a classification scenario. So with reset config dictionary, we basically load the default set of options and operators we have for classification. So they're given here. So there's a set of resamplers, transformers, classifiers. Basically what we've seen earlier in the slide, but this being the subset for the classification scenario. So we don't see any time series operators here. And if we would scroll down, we would see the default value details here regarding parameters, but that's not of interest for now. So there's now multiple methods we can use to modify the default scenario. Basically, we want to delete, for example, all the resamplers. We want to delete certain transformers, categorical PCA, supervised feature selection, label encoding, and 100 encoding. We want to just drop them. We want to simplify our scenario so we can make sure, for the purpose of this demo again, that we don't overload and have a long running AutoML scenario. Same is for the classifiers. We would drop support vector machine, naive base, multi-layer per set from, and update the configuration for multi-class logistic regression and the hybrid gradient boosting classifier, specifying some different than the default value ranges here. So that's something we would need to script here and specify. Certainly we can also load predefined, let's say, configuration. We'll see that in a later example, or I can also mention that in the time series scenario. There you would see how you can load JSON string for your configuration, which you have prepared before. But this would be an approach how you would define and modify that on the fly. And as you can see here, we have feature selection, supervised, scaling algorithm, the hybrid gradient boosting classifier, random decision trees, and the logistic regression classifier. Okay, a small set, but a good set, and of different algorithms. And we then finally call the fit method here to start the AutoML run here to come up with the best possible model. And we have been invoking the pipeline progress monitor, which gives us here the overview of potentially 47 pipelines to be calculated overall. We started with 15 and then had 4 generation times 8 would be 28. In some would be 47 potential pipelines to be executed here. And as we can see here, as we go from generation to generation, basically the overall process here stopped. We have 0 green and 0 red after generation 1 because we could not achieve any further improvement here with reference to the F1 score we have already achieved. So we have basically executed 15 plus 8, 23 different pipelines, and then we could go here into some of the details and yeah, even go into the ones more specifically and have a look at the specification of the execution of the pipeline as well as the performance statistics achieved regarding that pipeline. There's also execution logs available if we wanted more information. And certainly there's also an option now, as we said, there's always SQL generated on the fly. We, for example, use last execute statement. We would see what has been passed against the HANA Cloud instance. And as we see, there's the PAL AutoML fit SQL procedure being called, and our pipeline here passed in as a string in the end, the configuration. There's then multiple methods to, again, explore the pipelines, or the best pipeline can be explored here also directly using the pipeline plot function. We see it's a single step pipeline here with the hybrid gradient boosting classifier being called. If we want more information, we can use the best pipeline data frame object and collect our 5 best pipelines, which we wanted to generate as we specified this in the pipeline definition as the elite number of pipeline. That's the number of best pipelines we want to output from the AutoML run, and can then for enhanced graphical analysis call this best pipeline report, where let's see, could then get a more visual insight again. We can explore the different pipelines here and their performance, the statistics being plotted against each other for a more detailed analysis. And again, can graphically visually inspect the different pipelines. And if we go through the 5 best ones here, also visually, we see all of them would be, almost all of them would be single step pipeline. This one is actually a 3-step pipeline here. We could also have set constraints with the AutoML scenario definition saying the minimum number should be 2 operators in a sequence, or maximum should be 5 whatsoever. That all of that can be specified. And again, we could have also looked here at the runtime logs as well. Certainly, then if you want to apply the pipeline model, again, we can collect it from the model data frame of our AutoML object, collect the last one, or instance 0, which is the best one, where we would again see the complete model if we wanted to see it. And if it was a multi-step pipeline model here at the end, we would see then the other operators as part of the actual model. There's then the predict function, which applies our test data frame here against the best model and provide us with the respective predicted results. And yeah, as additional examples here, there's then also demo examples of how you can refit the pipeline, again, using the pipeline fit functions, how you can evaluate the pipeline. etc. Yeah, I think we still have some time, so maybe let's look at that. Here in this example, I'm specifying or extracting the best pipeline into a single object, and also the statistics into a distinct Python object here, and can then basically pass this in again to the fit function, saying I want to use this specific pipeline. In our case, it's the best pipeline, and execute the fit function. And basically with that, not train the complete scenario, but refit a given pipeline, which I've passed in here as a parameter to the object. And certainly I could again execute a predict function. And in this case, now we see that once we execute a predict of our AutoML object, we execute the pipeline predict functions. And certainly, again, we can look at the data sets here, and just for completeness, there's then also the evaluate function. If we want to probe our pipeline against our test data set and evaluate basically our pipeline model against this benchmark data set, and for example, look at the F1 score, etc. All right. The other examples which I've provided here target regression scenarios and time series forecasting scenario, which are pretty similar, but with some nuances with respect to regression and time series, which you are happy to explore. And let's see if we have time left. We can also briefly review the demo, a demo of those. But for now, I'd like to see if there's any question and open up for question and discussion.
Thank you, Christoph, for the detailed demo. I like that you used the time that we have here in the call. So far, there's no questions in the chat. So if you want to continue with demoing, you are free to do so.
Okay. Yeah, then maybe let's continue with the time series scenario, as this is the most, let's say, different. Regression is fairly similar to the classification. Again, I'm loading the package, connecting against the HANA Cloud instance here. In this case, I'm forecasting shampoo sales data, also very popular machine learning challenge data set or example data sets where we, as we can see here, have monthly sales values. The month's value here is a continuous integer number here. So the next year's January is 13. So for simplification, we just used an integer index here for the scenario. And rather new capability here in the Python machine learning client is that we have a time series report capability, which allows us to specifically decompose the time series data using this data analysis function, where we basically specify the actual column to forecast and the time-based key, which is here our month, and then can customize which pages we want to basically output as part of the report. We want to analyze stationarity, the autocorrelation, rolling mean and standard deviation as outputs. Want to see if there are any outliers, and basically build the time series report. And once we have done that, we basically get this time series report here, and can then go over the statistics here regarding stationarity or the autocorrelation being output here, or the rolling mean and standard deviation being plotted here. So it gives us an indication, a visual indication of our actual time series data before we go into the actual time series forecasting and selecting maybe specific algorithms which are applicable to the scenario. And here now I'm loading the automatic time series object. Similar to what we've done before, I'm specifying the scenario in a similar fashion. I have a different optimization target, root mean squared error, of course, for time series as one I could choose. It has a negative value, as the idea is here the value should be as small as possible. Therefore, that's the negative value definition. And what I've done different here in this scenario is I didn't use the methods to first load the default configuration and then the other methods to drop some of the methods and update the parameters. As basically I'm specifying here the JSON string in the first place, loading that into a Python object, and then I'm basically need to run this, of course, and then I'm basically passing this into the respective data frame object of my AutoML time series object. I'm loading that, and then similar to what we've seen for the AutoML classification, I'm then invoking the fit and actually then running my automated time series analysis scenario again to derive the best possible time series forecasting scenario here across multiple algorithms which I've specified here. Maybe we can have a short look at the algorithms used here: outlier detection for time series, value imputation for time series, Bayesian structured time series as also a relatively new algorithm, classic ARIMA. AMTS is our profit implementation additive model time series analysis is the acronym here, which has become very popular in many scenarios. We have customers using that for detecting machine failures, for example, so very popular in time series forecasting. And the classic exponential smoothing variance here being also part of the, let's say, defined scope of the AutoML scenario. And here again, I defined 3 generations, and I started off with 15. 2 executions failed. You could have a look why they failed. Maybe there's a data problem or a parameter problem. So that's also kind of given here. There's some missing values for sales. So this algorithm basically failed because we didn't, or as part of this pipeline, the values were not imputed or not in correct order. And again, based on the RMSE value, I'm seeing that I have some progress over generations. Maybe if I would have added more generations and a higher number of offsprings, etc., higher population size, basically a larger scenario scope, certainly the AutoML engine would have had more options to come up with even better values. And then again, I can use the best pipeline data frame result object from my AutoML object to see what are the best pipelines. And I can see here there's Bayesian structured time series being used, and exponential smoothing for the other two best possible pipelines. And again, I can also visually explore the statistics of the these three elite pipelines, or visually here, looking at the individual stats graphically, how they are plotted against each other, or the actual pipelines here. Pipeline 0 is always the best pipeline, where I see I have a sequence of outlier removal, imputation, and then Bayesian structured time series used against the data. So I think really a helpful approach to improve our modeling for, in this time series scenarios, but also for the classification and regression scenario. And certainly we can also, for the time series, use the predict function, and similar to other Python package, we have a nice utility function to create us a future data frame with kind of a horizon of 10 additional time series data points, and we can then simply predict against that. Yeah, maybe to summarize, our automated machine learning capabilities really target the expert data scientists to even benefit from more productivity and uplift in kind of the time invested to derive and build the best possible machine learning model using our predictive analysis library. The framework and the function and methods provided in our R and Python machine learning clients provide a comparable functionality experts are used to, certainly in the open source world. So overall, it should provide you with an improved time to come up with the best possible machine learning model of higher accuracy and value, and certainly business value for the actual applications where it's supposed to be used. And all that with our embedded machine learning function library, the predictive analysis library in SAP HANA. So I hope, this has been of interest for you, and maybe now we have additional questions, Lena.
Yes, indeed. There is one that came towards the end of your demo from Phil here in the chat. He would like to know whether you will also publish the notebooks and the data on which the logic is running on.
Yes, I've actually done so. So if we here in our samples repository, there's actually the notebooks and there's the data available. And if you have a HANA Cloud instance to utilize, then you could try this out directly. What you could also do is we actually do have a machine learning community challenge starting next Monday. We can also try out the AutoML capabilities against this new scenario, which we will share next Monday, 5 p.m. German time. So Lena, you may have already pasted kind of the link to this blog, where I hope many of you will register and join us for this machine learning challenge. And during then the time period of 3 or 4 weeks, you will have access to a HANA Cloud instance, where you can then also certainly try out the AutoML capabilities.
Yes, I shared in the chat the link to the event listing in groups, so everyone can indicate that they are attending the call on Monday, but I will definitely also here now share the link to Susan's blog post.
Yeah, exactly, the blog post, and here then the register link, I guess, then maybe that you have shared this one. We have already 42 people lined up, so if you want to join and try out the AutoML capabilities, we would be more than happy to have you as part of the team and group working with the HANA machine learning capabilities.
And to add to that, so I worked with the SAP HANA team in the last couple of weeks, supporting from a community perspective and engagement perspective on that challenge, and it put so much effort in it. We have a lot of open office hours for any questions that you have. So there is plenty of support where you can directly ask the questions to our experts. So I really am looking forward to this challenge that starts on Monday. Really cool, and I hope a lot of you will join as you're all interested in machine learning. With that, I have a question actually, Christoph. I was interested when you mentioned, and I don't have any clue about machine learning per se, but so you mentioned shampoo sales data is very popular in when you do your demos or in the data set. Why is shampoo the example of all the examples? Why shampoo?
No, what I was referring to is basically on, I mean, there's a couple of, let's say, community pages where there's machine learning challenges, and there are some popular classic challenges like the diabetes classification or shampoo sales or survivor predictions from the Titanic passenger list. And so now it's like this. So there's a series of popular challenges with, I don't know, simple data to just have something simple to explain a concept. And that's kind of, I don't think that the shampoo sales is, yeah, I don't know.
Okay.
I hope that this resonates. Yeah. So that's what I meant, at least. Yeah.
All right. Okay, great. Thanks for the clarification. Okay, with that, we're on time as we started quite a little later for this call today, but I hope everyone here on the call had a good insight. Thank you so much, Christoph, for your time demoing here to the SAP community. And I hope to see everyone on Monday for the next SAP community call.
All right. Yeah.
Take care, everyone.
Thank you, everyone. Have a good day. Bye-bye. Thank you.
Bye.